Hello and welcome everyone to our 21st FAIRWork webinar. Today we introduce to you an holistic perspective of our research, meaning that the project partners who were involved in our research will introduce what they have done in the past roughly 2.5 years since the project started. And before that, we will start with a short introduction to the project and an overview of how we conducted this research and FAIRWork in general. So myself I'm Christian Muck, and I have the honor to present the general parts and to guide through this webinar, then hand over to my partners with the research results. So what is FAIRWork? FAIRWork is an EU-funded project where we focused on creating, designing, and implementing the democratic AI-based decision support system. So the main goal is a piece of software, a prototype that considers this, but also we had a whole lot of research conducting it and influencing its design. So what are the main parts of this FAIRWork idea? In short, is we want to integrate the human perspective, so not only people using this decision support system, but also who are influenced by it, and what are their concerns, their needs, which influence decision making. Therefore, we need some algorithms which are represented on the right hand who handle this complexity, mainly coming from optimization and AI algorithms, which are then implemented and adapted to fit these decision problems that we have for these humans. For example, how can humans be assigned to production lines considering the needs of the business, so the project, the production plan, and also the human well-being, so how they're feeling, if they're ill or so on. Then we have on the bottom the knowledge base, which saves the data that we need from the production line itself, or about the vehicles, robots in it, protection plans, and so on, but also the human perspective, where we gather this information about this personal needs from the workers, for example, and then make it available to our AI services. And the main idea is that we want to have this more flexible and adaptive. There where we use this orchestration in the middle, where this orchestrator orchestrates the AI services with knowledge base and the results to the human beings for the user interface. So it connects all the available components that we have and provides it in a feasible way to the human users, being now the persons who have to make the decision or influenced by the decision. And last but not least, on the left-hand side, following this adaptive, flexible approach, we have a configuration environment, so tools, methods, guidelines, how we can create sophisticated AI support. We use some guidelines or conceptual modeling to identify the needed information, then provide it and configure the orchestrator and the services knowledge bit with it so that we can provide this decision support. So this is kind of the idea. How was the general approach, what we call condensation of AI approaches. So the idea of the FAIRWork project was or still is that we started with identifying the decision scenarios as the decision problems, the concrete ones, and then explored many different ways of finding solutions to it. So what is in this first layer here, the laboratory and experiments. So here we first conducted workshops where we gathered information directly from the people having these decision problems, and then explored very different low fidelity experiments on how we could solve this. They do not have to be necessary from the production domain for the same domain, but is a means of discussing ideas within the consortium so that we can identify feasible ones. So for example, we had very low fidelity ones where we created rules in Excel sheets with data, or more sophisticated one where we created a multi-agent systems working together in a predefined experimentation environment to create coffee and stuff like this. So this is really low fidelity from different domains, and then everything that was more feasible narrows down to the prototypes where we then really use the domain knowledge, so data from the domain, mocked or real data, and created prototypes that can be used. So single instances that can be first used and evaluated again and tested if they are feasible from the developer and the project consortium. For example, first prototype was using neural networks for resource allocation, or LLMs and React for machine maintenance. And then if they're deemed feasible, then they were integrated in the demonstrators, so with the orchestrator, the user interface, and deployed to be used by the domain experts from the production sites. So that we have really people who use these tools in the end can then give us feedback and say and evaluate how well this approach is fitting. And if this all is working, then we go to the exploitation items, where the companies involved in the project use the found knowledge that they created demonstrators to integrate them into their businesses and use them later on. This is kind of the FAIRWork idea, where the research was focused on these first two levels, these experiments and prototypes. And to structure our research, we identified 7 research tracks, led by different partners with the different foci, of course, and then all influence together the FAIRWork project. So, short introduction. At the top, we have the democratization of decision-making in socio-technical systems, where our colleagues from RWTH HumeTech analyzed and researched how democratic concepts can be considered in decision support systems to better consider the humans and integrate them into the system. The next would then be the decision-making using multi-agent systems, where our colleagues from MORE investigated how decision-making with multi-agent systems can be done. So what is the potential of decentralized decision-making using this agent representation, how we can integrate technical, human-centric, and ethical views. The next one is then the digital human factors analytics research tracks led by our partner UNM Research, which focuses on gathering information from humans and understanding this critical information on the humans about the physiological, cognitive, emotional, and resistant states using wearable sensors and sensors from the context of this human, so that we can then use this information in the decision-making process. The next research track is optimization in decision support systems, where our colleagues also from UNM Research analyzed and focused on identifying goals in AI-driven manufacturing and how the various techniques can be used and which techniques can be utilized in manufacturing companies. The next one related to it is AI-enriched decision support systems, which is led by VCL RWTH, and which focused on how AI techniques can be used for decision support, with a focus on machine learning approaches to tackle more complex problems, and also how we can categorize these decision support system types to write a catalog that people can identify the best fitting approaches to their needs, so that developers can find fitting approaches. The next was then led by BSc and OMILAB together, so where we focused on model-based knowledge engineering for decision support, meaning that we how we can gather information from the decision scenario to deployed decision service, and what steps do we need, and how we can support this with methods and approaches mainly focused on conceptual modeling in our case. So what do we need and what information do we have to gather to accomplish that? And last but not least, reliable and trustworthy AI from our colleagues from RWTH VZL again, which focused on how we can build trust in our system. So not only by the implementer of the decision support services, but also from the persons involved or influenced by this made or proposed decision. So how can we build this trust that we can then easier be used and integrated into the company, which is main part here would be then the transparency that can lead to more trust. So this is a short introduction of our research tracks. And now I want to hand over to the first one. And now we go over to introducing the research tracks in more details and the key findings. And we start with the democratization of decision-making in social technical settings. And I hand over to Professor Stefan Böttcher from RWTH HumeTech.
Yeah, thank you very much for this starting. If you look at the next slide, then we can see the point here, how we made it. So it's mainly a question of how we design socio-technical settings, and thereby it's not only about technology; it's as well about social organization of technology. That's really important to know. Now, if you look really at questions of democratization, then it's about collective orders. And in companies, we have specific forms of collective orders. And with regard to this multifaceted question of how and whether AI tools might enhance democratic decision making in companies, first of all, we have to look at the concrete settings in companies. And here you see how we did this. So in fact, we had three empirical phases. The first was about onboarding. It's about participation and to learn something about what are questions at companies with regard to introducing such tools. And in the second phase, we named precision. It was about to learn the details of how implementation processes might happen with regard to these technologies. And finally, we're in the contextualization phase, where we then raise specific questions of how to implement these kind of technologies in companies. If you take a look at the next slide, we see that there is a point we can really raise, or we should raise, in fact, because if you see democracy, it's typically aligned to a form of governing societies. And therefore, it's clear democracy in a company is really a specified form of democracy. Because yeah, it's easy to imagine. In companies, we have established hierarchical structures of decision making. So it's really not at the beginning democratic, but it's more a hierarchical form of decision making. And that's the strength of companies, to have clear decision rules and clear ways how to steer the next ways and innovation pathways. So nevertheless, there are established institutions of representation of workers' rights, for example, the Staff Council. And therefore, against this background, we have to have a really clear and precise look at the socio-technical arrangements which emerge with this kind of technology. So it's about creating opportunities of specified representation via multi-agent systems, and therefore, at the same time, the question of limiting direct representation via multi-agent systems. So it's an opportunity, but as well a threat, which might come up, and therefore we have to be careful with such systems. Moreover, as technical agents, as members of this collective, step in. So we have to be therefore really precise with how democratic structures are shaped via this implementation of such systems. We did this, if you look at the next slide, with a clear study of looking at specific features like decision-making, involvement, expectation of workers, and specific challenges which took place. You see here an overview of these different results, which I would not like to look in detail at this moment, but it's clear that we have to carefully look at the relevant practices of actors which are at place. So summing up with the next slide, we can say there are specific features which are important for democratic AI in companies. And you see here, and that's not by accident, that these bubbles are differently large in their shape. And you see here that representation is the most important thing here. The representation of the workers within the system has to be really carefully looked at. And moreover, you see here accountability, learning implementation, empowerment, and customizability as relevant features. In this, so to speak, choreography of different features, we have to take into consideration. And with this, I hand over to the next speaker.
Thank you very much. And the next speaker is Gustavo Vieira from MORE, which focused on this decision-making using the multi-agent systems. And with this, I hand over to you, Gustavo, and your presentation.
Thank you very much, Christian. So I will present the highlights of the decision-making using multi-agent systems research track. So in the first slide, if you could go to the first slide, Christian. Thank you so much. So I'd like to begin by highlighting how Industry 4.0 has allowed the realization of interconnected environments defined by decentralized resources. Multi-agent systems have emerged as a powerful architectural approach in this context, enabling distributed decision-making through the agentification of stakeholders. MAS, as I call MAS, is capable of representing stakeholders in decision-making processes and digitize collaboration and negotiation mechanisms in direction of desired goals for each process. Decision-making now employ multi-agent systems to address distributed and complex challenges. And with human factors, we have human-centric decision support systems. As we transition toward Industry 5.0, the incorporation of human data into agent-based decision-making becomes fundamental. This integration facilitates more personalized, adaptive, and ethically informed processes that prioritize human well-being and societal impact, as Boshin was just saying about this type of systems. So being ethics, a foundational pillar that ensures responsible agent behavior, aligning autonomous decisions with societal values, which I'll point in the next slides. So in this next slide, I'd like to highlight that the multi-agent system developed for this research was applied to a resource allocation problem in which the service recommends allocations of workers to production lines. They provide the worker allocation recommendations before each shift in this automotive industry setting, matching the profiles of workers to the production line requirements using the resilience score and preference of workers as human-centered data. The system objectively ensures that the agent interactions and negotiation exchange remain guided by human-centric values. So with this, it enhances human participation in decision processes. It creates a decision framework even in constrained industrial settings through balancing relevant human data with production demands, presenting a high relevance in complex industrial settings by balancing objectives and constraints. We talk here about multi-agent systems enabling a democratic decision framework by representing stakeholders and modeling their interactions, allowing for decentralized negotiation and coordination that reflects both organizational goals and individual perspectives, as the technical system can make. So naturally, there are some limitations that our colleagues analyze. And then in the next slide, in this resource allocation solution, we proposed an ethical watchdog mechanism that was developed to act upon these ethical aspects of industrial scenarios. Its objective is to assist the decision-making in aligning to ethical decisions. Embedding ethics into agent systems enables them to make decisions that are not only efficient, but also build trust among the stakeholders. This ethical layer is fundamental, as the actions of the autonomous agents can significantly affect individuals and their well-being. The ethical watchdog is an agent in the agent system that continuously monitors the decision process outcome to protect the system against biases. It's conceived as an agent that identifies whether the outcome abides by the expected ethical aspects related to the industrial use case. This mechanism emphasizes the need for human-centric oversight. The watchdog analyzes the ethical alignment of the system outcome and provides a mechanism to correct potential ethical diversions. It considers parameters relevant for the given use case and adapts the original recommendation to a solution that abides by this expected ethical aspect. And at the end, it requires the oversight of the human decision maker to select the revised proposition by the watchdog as the final decision. And in this last slide, I'd like to wrap up the highlights. So we have the multi-agent system that model individual stakeholders, such as the workers and production lines, in interaction exchange to balance worker needs with production requirements. Also complementing, we developed an ethical watchdog mechanism that is an additional agent that monitors the ethical suitability of outcomes within the multi-agent system in order to help the decision maker to become aware of potential ethical violations and trigger a renegotiation of this resource allocation. And also, we have an enhanced coordination of the decision process via the agent workflows, defining interactions and coordination between the agents to ensure that these tasks can be broken down into manageable subtasks. And as a prospect for the future, we see that generative AI presents potential new solutions using agentic architectures. This empowers the multi-agent systems to handle evolving industrial scenarios with enhanced flexibility. So thank you very much, and I'd like to hand over to the next presenter.
Thank you very much. Our next presenter is Dr. Jochen Mosbacher from UNAM Research, who will introduce the Digital Human Factors Analytics research tracks. And with this, I hand over to you, Dr. Mosbacher.
Well, thank you very much. And thanks for going on to the first slide. So as we have heard from the colleagues, the idea of Industry 5.0 focuses on the workers and places the workers' well-being at the center. And our idea here is to use human-centric technology to improve the resilience of the workforce. Resilience of an individual or a system means its ability to cope with stress, to regenerate and to bounce back from prolonged strain without detrimental effects. And of course, an important aspect thereby will be to assess the human factors, monitor stress, strain, but also the resources and the resilience of the individuals to be able to alert for distress, prolonged toxic stress, and to optimize the workload for each individual. And if we go on to the next slide, you can see some first explanatory work we did was to get insights into the relationship between stress and resilience. And what we did, we applied some wearable technologies in our human factors lab and simulated typically workplace situations with intensive physical strain or intensive cognitive emotional strain to analyze the relationships and the effects of the strain on the person's physiological markers and resilience. And currently it is planned to collect real-life data at the Stellantis manufacturing site. And on the next slide, we can see some first results from a short research we did at the factories of Flex in Althofen and Timisoara. They were mostly about the acceptance of wearable technologies and the typical demands placed on the workforce in their day-to-day life. And you can see in the upper figure that most participants could see themselves wearing smartwatches and sensor shirts, even for long-term monitoring. Smart glasses, on the other hand, were widely rejected. And regarding the demands, I think there is another figure. Thanks. Yes, exactly. We found that decision makers, management personnel, but also shop floor workers all reported phases of high mental demand as at least a daily occurrence, sometimes even multiple phases a day. And well, these insights were discussed by some colleagues of mine with decision makers and workers of the Flex Timisoara factory at the last workshop. And all this information will then be incorporated in the model that we see on the next slide of stress and resilience. So basically, we assume that every task and the demands workers face in their day-to-day life will put some strain on a person. And the idea is to use wearable technology to measure physically the effects of physical strain and cognitive strain on a person in proxy by physical markers, and use this to estimate the mental exhaustion, the need for recovery on the one hand, but also, and here we will also use data collecting the free time and the regeneration phases of the persons to assess the coping capacities, resources, and the resilience scores of a person, which will have positive effects of mental exhaustion. And all this information will then be provided for the mass decision support system. And finally, what currently is done by some colleagues is assessment and ideas to minimize the effects of measurement and representation bias, and work on statistical problems to optimize the machine learning approaches in the model. Thank you very much, and I will hand over to the next speaker.
Thank you very much. Then we hand over to our other colleague from Union Research, Herwig Zeiner, who focuses more on optimization in decision support systems. And the stage is yours.
Thank you. Can you move to the next slide, please? So in our research track, we are working here on optimization stuff. The key point is that we want to know, the most important point is what is the process and how can decision making be optimized. There are different ways. First of all, you need an optimization goal. Then you define maybe several approaches and you choose the best one. But there are also sometimes more ways to go because it's not always clear what is the optimized one when you have multiple parameters. Then you implement it. Afterwards, you do the research and then evaluate it. Next slide, please. And when you do the research, it depends a bit if you want to automate the process or optimize the process. This depends then on the method which you choose. For example, when you go to logistic problems and you do some scheduling, normally you define optimize something, and then you define the optimal goal, and you try to go as far as close to the optimized goal, so to speak. When you want to automate something, it's a little bit different approach. You define normally a baseline and you check how faster you can make the process, and you can measure it in the sense that you maybe reduce resources for applying it or make the process faster, and then you have indirect resource gain. This depends a little bit on the industrial process where you apply it. And on the next slide, you see one concrete example. What does it mean? For example, we have carried out an optimization process for Flex where we validate calibration documents. Currently, they are checked manually. They have a very large number of documents. So what we have done, we have automated in the sense that we check with a rule-based approach different stuff in the document. For example, if the certificate issue date lies in the past, if the calibration device document matches with the name stated in the document, or if the certificate was issued only after the verification measurements. This is the use case is very critical for production companies because they have on a regular basis do this calibration, and in our case they have about more than 3,000 documents, and this is crucial to check it regularly. Please go on the next slide. And here you say, as an example, we have this done, and then we have give them a report if this certification document is valid or not. And check it. And now in this process, this is great help for this company. We are in the process to validate it and to check most of the validation as a calibration document in this way. There are 4 different types, and we get and improve the process quite a lot, and so that the documents which need to be checked manually are getting very small amount, and in this way we could improve the process and automate it as much as possible. And as you see here in the example, this is practical example when you introduce IE in the company. In our way we have chosen a hybrid approach, a rule-based approach combined with AI stuff by scanning and checking documents. And in the end, it's great value for the company because it's needs less resources from them to check this type of documents, which be done regularly. Thank you very much. And now I hand over to the next speaker.
Thank you very much. So now we come to the fifth research track, AI-enriched decision support systems, where Silvia Olbrich, our colleague from RWTH WZL, will introduce these research tracks and their key results. The stage is yours.
Thank you, Christian. I would wait for the next slide so that I could introduce some of our main pillars that we worked on in this project. And they are following. We worked quite a lot on guidelines and recommendations, and our focus was to create approaches for the developers that are dealing with development of the artificial intelligence tools or machine learning tools, speaking speaking a little more concrete. We also worked on identifying existing AI applications and validated use cases in publications in order to generate a machine learning catalog that can be then used as a baseline for discussions between industry and academia, what is possible up there, what already has been checked, which level of the implementation it already had. So that was the second part. And the third one, which was the widest one, is an AI-based optimizing solutions for industry. Here we used the expertise and the knowledge gain from different sources like publications, conferences, journals, as well as the discussions with industrial partners to identify potential use cases where we could generate some prototypes of services, and that would also lead to create a prototype for this project in another set of work package that I really encourage you to check, not only this part of the project but also our development and implementation, where you can find it even more in depth. Christian, could I please, next slide? Yes, so actually it's a bit here automated. So we actually defined some questions that were helping us to keep the track in the project, and for guidelines recommendations, we try to answer the question on how these existing methodologies can enrich classical decision support systems in order to apply in complex dynamic manufacturing processes. Why is it important? Is it important because decision support systems is nothing new. It's been up there since many years. However, the implementation of AI services within them, it's still quite a hurdle for industry. So it was quite important, and it's still quite important to find the ways and guidelines for developers and industry on how to do that in the best way, to use the old devices, old setup infrastructures with new technology. Yeah, Christian? So the second part is on how can the decision-making process and architectures in the manufacturing environment be accelerated for AI methodologies. And that's, as I mentioned, it's basically really checking the validated approaches that already have been used, and finding the information that could help us doing it for the other applications. And the last and the biggest and the widest one where we were working, it was focused on finding the answer to the question on how to different optimization metrics or constraints affect the schedule in manufacturing context, and how and to what extent can AI techniques be utilized for optimization in industrial scheduling? So as you already see here, the really big part was the reinforcement learning on which we focused, but not the only one. We also focus on a few different approaches that will be shown in like few slides. So what was the output of our work? When it comes to guidelines recommendations, you can also, we created a novel decision support system classification. You can see just one screenshot from the paper that, of course, it's available open source. You can check it, read it, really would suggest to do it if you are interested in the topic. What methodologies we used here? We used a survey and through the literature review, and based on that, we identified different types of the problems in the industrial applications, and through that, we derived 4 main classifications. The biggest contribution here, with comparison to the previous classifications, is the learning-based decision support systems when we are now discussing machine learning approaches. Next click. The main output from the research on existing application is catalog of validated machine learning approaches in industry. So the methodology used here was a systematic literature review, and focus was on resource and production planning, the different decision levels and the different machine learning methodologies applied. And the last part that was the main focus on our research was the application on various methodologies on our use cases. As you can see in the services, we have inventory management with reinforcement learning, safety efficiency ranking, resource allocation. And for resource allocation, we used like free methodologies, genetic algorithms, neural networks, linear assignment solvers. What here can be really interesting for you is to visit 2 also papers mentioned below this graphic, as well as the GitHub. What was a nice contribution in this project, we tried to document everything that we've done. So for the prototypes as well as for our demonstrator in another work package within this project, you can always find our documentation in a GitHub. Thank you so much, and I will hand over to the next speaker.
So thank you very much. The next research direct will be introduced by Marlene Meyer from BOC and will focus on the model-based knowledge engineering for decision support. The stage is yours.
Thank you, Christian. Please directly jump to the next slide. Yes, exactly. So as an introduction, the focus of this research track is really on closing the semantic gap between semi-formal human user models and well-formalized models for AI algorithms. And in our research, we placed two main questions. The first one was how can we really use now models to support getting AI into companies, and more specifically, what type of models are needed to identify, to specify, or to configure AI. And for this, we applied a 3-layered approach, and this approach includes the identification layer, which is asking the question, what is the problem setting in general? What are specific goals? What are important aspects that need to be covered? Here, the capturing of relevant information, parameters, goals, and KPIs is targeted. Then the second layer is about specification. So here we ask how conceptual-wise, how can the problem solving be supported? How does an AI algorithm have to behave to decide what is the decision logic of such an AI algorithm to get to the desired output? And then on the third layer, we have the configuration. And here we ask more or less how to technical-wise configure an executable AI service. And this really deals with the implementation of a concrete application or algorithm. So next slide, please. Exactly. So in the first step, we, based on those 3-layered approach, we mapped materials, models, or prototype to the corresponding layers. So for example, experiments were made with design thinking workshops in the identification layer to illustrate the use case, to depict the problem setting there, or deliverables like deliverable 2.1 was prepared to describe and document those use cases. Or on the specification layer, we have depicted and we have prepared an Excel or an experiment based on Excel to depict really decision logic for AI algorithms or for such a decision-making process and so on. Next, please. Exactly. And then based or more or less in the second part of this research, we mapped really models and modeling techniques to those items that I just mentioned a few. So for example, one model would be natural text as a non-formal way to describe problem settings. For example, this would correspond to deliverables, but also business process modeling notation, so BPMN, to describe business process models, process sequences, but also to describe the decision making process elements that we depicted. And for example, for the configuration layer, we mapped their computational AI models like constraint programming models or large language models using RAG and so on. Next, please. Yeah, just as an information, we did this for CRF and Flex, but also, of course, there are other use cases which should be depicted with the ... in the third column in this initial picture. Yeah, besides this mapping of those models to those different layers, and as a starting point, we then proceeded to identify so-called AI interaction patterns, where we aim to depict really the sequence and interaction between high-level building blocks of the DAI-DSS prototype for configuring a certain AI prototype. And for this, we differentiate between conceptual or domain models and also technical models. So, for example, when we look on the right picture now, we see that the interaction workflow for machine maintenance using large language models and RAG is depicted. Conceptual-wise, this AI prototype or demonstrator starts with a prompt that is requested by the user input and is requested by the user through the user interface. So this initial component under technical model and the box on the bottom or on the top, sorry. And this is then decomposed by the AI in its main topics, and then it's used for really querying in the enterprise architecture model the different data sources. This enterprise architecture model is more or less a concept model which we created for this prototype that depicts different information about different data sources and which data source is most suitable to be used and the AI should retrieve its answer from. Exactly, with that instruction, the data source is queried, and this data source is coming from the knowledge base, which uses more or less a vector database. And the final answer is then again composed by the AI and sent to the user through the same UI that the prompt was received. So this sequence is more or less shown in the technical model. And we have those conceptual steps now that really have been implemented technical-wise, for example, using OpenAI large language model as artificial intelligence, but also ADO-IT for the enterprise architecture modeling environment and OpenSearch vector database as a knowledge base to retrieve answers from. And we used Olive as the configurator, which is in the technical model, the middle part. Next slide, please, Christian. Exactly. Besides besides this conceptual and technical models being used for modeling for AI, we also have a contribution of OmniLab here. OmniLab focused here mainly on how the model value or how model value can be improved, but also by reusing modeled information from one layer in another one, or how information can be looped back again to the models to depict really information from suggested decision solutions in models. And reusing already modeled information reduces, on the one hand, manual work, but also the looping of the information back improves really the expressiveness of the models. So especially regarding the explanation of concretely made decisions in decision scenarios. Yeah, with that, I would hand over to my colleague, Johannes.
Thank you for this introduction. And now we come to our 7th and last research track for the day, but nonetheless a very important one, which is reliable and trustworthy AI. And here our colleague Johannes Zisk from RWTH WZL will introduce their findings. The stage is yours.
Perfect. Thank you very much. Let's directly jump into the this last research track focusing on trustworthy AI. We tried to approach this topic in this project through the field of AI transparency, which can be viewed from 2 different perspectives. First one is that of explainability, focusing more on AI experts and developers. And the other perspective is that of understandability, focusing more on lay users and their acceptance, trust, and usage. On the next slide, we can see that in this project, we try to answer this left question. So what is technically possible and how can transparency be technically implemented by conducting workshops with the different service partners in the FAIRWork project and by developing AI advice for AI service developers, which we did based on our findings from the experiments and scientific studies that we did to answer this right-hand side of the graphic. Then on the next slide, we can see that we started the process by finding out employees' fears and hopes when thinking about the use of an AI-based decision support system, where we found that there is a great need for transparency of an AI system. And we then dove deeper into this topic to find more details on the next slide, where we can see the focus group discussions that we conducted to find out lay user requirements towards transparent AI. And here on the right side, our quantitative study that we did to compare different types of transparency and their effects on trust in the system. On the next slide, we can see some of our conclusions. So we saw that transparency is very important for trust, but it must be implemented in an understandable way. Background information and AI reliability information are very important for building trust. Global explanations, so explanations on the system as a whole, are necessary, especially for trust formation, while local explanations, so explanations taking a look at single results, are especially useful in cases of unexpected outcomes or mistakes. So when we then take a look at how these findings can be implemented technically on the next slide, we conducted multiple workshops with the technical partners from the FAIRWork consortium, as there were many different technical solutions and AI systems developed that work very differently and thus need different approaches towards transparency. We also developed AI transparency guidelines and a matrix. If you click one more time, then you can see that this matrix is currently in the process of being published, but we did test the guidelines and the matrix together with the FAIRWork service partners to apply it to the different services, which we can have a short look at on the next slide, because there are many different technical solutions and services in the FAIRWork context. And we tried to approach each of the services individually by applying our guidelines that we formulated based on our research findings and the studies that we conducted, to take a look at how can we apply transparency for each of the services on a global level as well as a local level, and how can other types of transparency, like, for example, background information or accuracy information, be implemented in the different services. If you go to the next and last slide, you have a like short overview over the research that we conducted in this research track. So if we take a look at the right-hand side first, we saw our focus on understandability with lay users, especially to find out what their requirements for transparency are and what the effects of transparency are for them in multiple studies that we conducted. And based on that, we built a transparency matrix and transparency guidelines, which we then used on the left side to see how these findings can be technically implemented into the different services that are existent in the FAIRWork context, together with the service partners in workshops, and by applying the matrix. That's it from my side. Thank you very much. And I hand over back to you, Christian.
Thank you very much. This is now the introductions of our research tracks. And the last point on our agenda today is a discussion about the content and aspects of the research, which will be guided by Professor Stefan Böschel. Therefore, I hand over back to him to start our discussion.
Yeah, it's a wonderful opportunity after all this research done, and to come into a conversation about some really fundamental questions which are taking place with regard to whether and how this question of democracy is really well put in this regard of implementing AI tools at companies as a means to strengthen democracy in companies at the same time. So, and therefore, there are three questions, but I would say a lot of more, but three we can spot on. First, democracy in companies really specified democracy. So we have to be really clear with this boundary condition that it's not democracy as a whole, which is a really multifaceted system of governing collectives. And therefore, it's up to us really to ask ourselves constantly, does the shown features of specified democracy support the claim of democracy in companies? So what is really the, so to speak, the shape and the form of how it really relates to the whole setting we should look at. A second question, which is important to see, that these socio-technical arrangements we looked at create opportunities, but at the same time create limitations. And therefore, it's really important to look at the multi-agent simulation tool, which is part of a socio-technical arrangement. And therefore, we have to ask ourselves, are the identified dimensions sufficient to analyze the settings of opportunities and their limitations? And the third thing is to look about really the shaping of democratic structures in companies, but not only there, so it's really about to have a clear look at the context. So at the moment, democracies are under pressure because there is a lot of authoritarian dynamics happening, and therefore companies might really places really to stimulate further of dynamics for democratization, but at the same time, it might turn out to the opposite. Think about Elon Musk. Their starting was really a democratic turn. He turned into a really authoritarian guy. And therefore, at the same time, we have to be really careful about these processes. And I would claim it's always about thinking the institutional order of societies, and that's really an important part here. What is technologies of decision support and the embedding context are aligned to each other, and are we really are they really, so to speak, institutionalized, saved? These are some questions to put the different ties together, and therefore now I would be really happy to hear some thoughts about this from you.
So can you hear me?
Yes.
So thank you for this for these questions. They're all three really interesting, and I think if we could speak the whole day about them. I'm from the technical part, and for me, and I probably think as well for Gustavo, it's also another aspect when you speak about the democratization between agents in the system. So I think here we have even another kind of a layer type sort of a democracy when we started to speak about some technical aspects and the agents that are there representing a specific even entities or really people or a manager or the whole logistics, for example, in the system. So I think that what I really took from the research in this project as well is that talking about a certain keywords like democracy really is main-folded, like for you, Stefan, as for us. And it was really interesting to work on it and to learn and to remember that everyone understands terminology differently.
Yeah, and proceed then with this and different understandings. That's true. And you mentioned a really important thing, Silvia, here, because it's with regard to the second question here, the socio-technical arrangements, that really we have to be much more careful with the technical agents taking place and whether they are, so to speak, actors in a democratic sense then. And therefore really to, rethink about who are the actors in such a form, in such processes of democratization. And we are perhaps too narrow if you only think about humans as relevant actors in this scene. That's true.
That's exactly, it's really mixed. It's really mixed, and the validation of each of actor, it's also next question basically on the list.
Yeah, thank you.
Thank you.
Exactly, Silva. Thank you for your comments. And I would like to add that this social technical study is really important in terms of analyzing and identifying such limitations of our technical systems, since definitely they are not able to substitute, and the intention is not to substitute the human, but provide support in the decision making. And we sure have even more now, more tools to support these decisions, and the multi-agent system comes as a type of technology, if I may say, to support this decision, and now representing humans with our human factors data that we can rely on, which is a interesting innovation point. And even more, we can see now with new developments regarding the large language models that these agentic systems are having even more opportunities to provide these added values, and we'll definitely see and we'll hear more about multi-agent systems in the future. And this analysis about these socio-technical aspects are definitely important. In our internal discussions, we have many exchanges in terms of how we could provide this ethical watchdog and provide the support for the decision making when we can definitely consider the ethical aspects of a specified case. We can then provide some sort of support and implement this through a type of entity that is capable of monitoring such ethical aspects as one possible solution, but naturally there are limitations in terms of the social technical aspects that the system is. That's a complementary comment I would make regarding this second question.
And it's really an important one. Thanks, Gustavo, for this, and because it shows again that although there are really good technologies, tools, it's really about the careful implementation, which is really context sensitive with regard to the social processes, and it's also really an insight that we cannot avoid the social processes. We cannot automate all these questions and say, well, here is a cool technology, let's do it by technology. These decisions, it's about decision support. And then at the same time, it's really a social process of learning within companies, of adjusting in companies, of really reshaping practices, but at the same time, leaving the authority in these mixed settings as well at the humans and not to replace them out of the system.
Yeah, I agree with you, Stefan, and I think that's also a very important point for trust in this system, like how much control is left with the human operators and how much is their process automated. And I think that also fits well into the question of democracy. So is the system maybe designed in such a way to enable more input and participation from the operators because it can maybe include more parameters than a human can, for example, worker preferences for scheduling tasks, or is it the other way around, like because the human does not sit in the center anymore of tasks that were previously entirely human tasks?
Mm. Yeah, that's a really important thing you raised, Johannes, with regard to the question of control. It's about creating new opportunities, but then the question is how to have a setting where we have a good feeling with regard to the control question. So, and it's about who is in the driver's seat and why, and these are really typical questions of legitimacy in democratic systems, and therefore it's important also here to know really where the places of control are and whether they are legitimate with regard to the procedures having these positions installed. That's a good question, and one we did not raise that much in our project so far, but it's a really cool point with regard to future research on these topics. And I would say, thank you very much. And it's up to you, Christian.
And thank you for this interesting and insightful discussion. We have two small things still on the agenda, so the kind of the closing. First, I want to say that this remind more that this is a overview webinar. So this is a very short introduction of all the different research that was done. And we have also for each part and research tracks more dedicated webinars with their own time span focusing on this particular part. So we already have done two, one to the democratization of decision making and this one for a reliable and trustworthy AI. And the others one are still coming, with the next being on April 10th. So the plan for AI-enriched decision support systems. So if you're interested, keep checked, stay on our LinkedIn page so you are informed. And then with this, we hope we stay in touch. And with this, the 21st webinar is over. Thank you everyone for participating and also everyone for contributing and preparing the slides and presenting the interesting topics. Then see you, bye, and see you soon at the next webinar.